Hello everyone, welcome back to my Rsubread video tutorial. In my previous video tutorial, we built the index for human genome reference HG38 and also we performed the sequence alignment for the first sample donor 1 0 hours and we created the donor 1 0 BAM file. As I mentioned in my first video, you can perform the alignment one by one for the rest samples. I have 6 sequencing samples here from 3 different donors, but this takes time to write the code for each sample. So today I'm going to show you how to create the code and perform the sequencing alignment for all the samples. So to do so, we need to produce a text file called the target. We can open the target and have a look. So you can see we have the first column as sample type. Because we have the samples from 3 donors, donor 1, donor 2, and donor 3 at 0 hours. That's the monocyte just purified from the blood and immediately subject for mRNA extraction. And also we have samples for 24 hours from each donor. Those samples are the RNA sequencing data after monocyte purification and 24 hours culture, then subject to mRNA extraction. So you can see the sample type we have sample 0 hours and sample 24 hours. Each time point we have 3 repeats. And for the input files 1, we have the sequencing read file 1 for each dataset. And in the column input file 2, we have the sequence read file 2 for each sample. Then in the output file, we have the BAM file name for each sample. This is the file that we are going to create after the sequencing alignment. So now we can go to R and read this target file name in. So let's read the targets as target. We can run. You can see now we have the targets data file. In the data window, we can click the file and have a look. So you can see we have the sample type column, input file 1 and the input file 2 column, and the output file column. So I introduce the sample name file 1 and the file 2 name and also the output file. So now we can use this target folder and do the alignment for all the samples. Again, in case you just have one reading, you just need to set the file 1 as the target input file 1, then file 2 as null, and then the output files will be the output file name in the target. Because my samples are from human monocyte, so we can use the index as HG38 reference that we built in video 1. Because my samples are paired and sequencing, I have sequence read file 1 and the sequence read file 2 for each sample. So I'm going to perform the paired and alignment again here. So I can set the index as the HG38 reference we built in previous video. Then set the read file 1 as the input file's name in the target file and read file 2 as the input files in the target file. So you know I have 6 samples. So in total I have 12 files here to do the alignment. Then we use the output file names from the output file column in the target file to name each BAM file that we are going to create for each sample. So now we can run the sequence alignment for each sample to create the BAM files. So let's run. So you can see Rsubread is running. You can see first it check the input rates, then initialize the memory objects, estimate the mean read length. Also, it start to create the output BAM file, check the index, that's the HG38 index. So you can see the global environment is initialized. Rsubread started to read the mapping in chunks. At the moment, it's 6% completed for the first sample. Okay, you can see Rsubread is doing the alignment. Then we can have a look at the console windows to see how the program is running. So first you can see Rsubread started the read alignment for our first sample, $1 hours. You can see the input file 1 is $101. Input file 2 is $10 hour 2. Then the output file name is $10 hour BAM. And the index name, we set it as HG38 reference. So here is the parameters that Rsubread created for the first sample. You can see for the first sample, the running started from 12 past 9. Then Rsubread is doing the alignment from 0% until 99%. Then you can see Rsubread completed the alignment for our first sample successfully. And here is the summary table, and it took nearly 46 minutes to align the sequence reading for our first sample. After that, Rsubread start to do the alignment for the second sample. You can see the input file 1 now it's $201. Input file 2 is $20 hour 2, and the output file name is $20 hour BAM, and again the index name will be HG38 reference, and here are the parameters, and you can see Rsubread started the alignment for the second sample at nearly 58 past 9. Then Rsubread start from the alignment 0 until, so at the moment it's only finished 87%. So you can see Rsubread will do the alignment one sample by one sample, because we name all the samples and the output names in the target file. So we don't need to write the code for each samples now. So you can see the first sample took nearly 46 minutes. So in total, for 6 samples, it will take more than 5 hours to finish the alignment for all the samples. So I will stop talking from here and let the program to run. We can come back to see the final result for all the samples. Okay, Rsubread finished the alignment for all my 6 samples. You can see here is the summary table for the alignment. During the result mapping, Rsubread created a BAM file for each sample. So you can see $1 0 BAM, $2 0 BAM, and $3 0 BAM, and also $1 24 hours, $2 24 hours, and $3 24 hours. If you have a look at my Rsubread folder, you can see now we have the BAM files for the $1 0 hours, $1 24 hours, then $2 0 hours, $2 24 hours, and $3 0 hours, and $3 24 hours. So we finish the sequencing alignment for all the samples. Now we can run the feature count for all the samples. Again, if you just have single-ended alignment, you can use the code here. In this code, you don't need to set the is paired and argument is true because I have paired and alignment, so I'm going to use the code down here to set the is paired and is true. We can set the file's name in the output file column of the target field. Then inbuild the annotation file as HG38. So in this way, if we run the feature count, we will count the mapped rate for genomic features for all 6 samples. So let's run the feature count. You can see Rsubread is processing the first file $1 0 hours BAM. So this step should be much quicker than the alignment. You can see we finished the feature count for the 0 hours $1 sample. It's just 1.19 minutes. Now Rsubread start to process the second BAM file $2 0 hours. Okay, so it is done. You can see the feature count process is very quick. The process for each sample is under 2 minutes. So now we have the feature count result for all 6 samples. So feature count returns a Rlist object. You can see here it has 4 lists. We can click the data and have a look. You can see we have the count for 6 samples, and in the annotation we have the gene ID, chromosome information, the start position and the end position, then strength and the length. In the status note, you can see the feature count information for $1 0 BAM, $2, $3 0 BAM, then $1, $2, $3 24 hours BAM. Because the feature count result was saved in the count data slot, then we can have a look at the first 5 count results for our samples. Let's run. You can see we have the first 5 rows. The row names are the gene ID for 6 samples. You can see $1, 2, 3, 0 hours, $1, 2, 3, 24 hours. You can see the count for the second gene is quite high in all the samples. And also you can look at the annotation result for the feature count. For example, we can have a look at the gene ID and the length. We can write again. You can see the first column is the gene ID and the second column is the length for this gene in our sequencing dataset. So we finished the feature count. Now we can create a DGE list object. We can use this DGE list object to perform differentially express the gene analysis between 24 hours and 0 hours. So let's create the DGE list object first. Then the count will be the count from the feature count data slot. And the gene information will be the gene ID and the length. So let's create the DGE list object. You can see we have a formal class DGE list. Now we can do the data filtering to just keep genes that have at least 10 rate per million mapped rate, and also genes that are expressed at least in 2 libraries. So we can perform filter genes. Now we can create a design matrix for the HR analysis. First, we can get the sample type information, then the design matrix, and also the column information. So now we can perform Womb normalization method to normalize the data. In this way, we will normalize all my samples. Let's run. So you can see in the plot windows, we can see the mean variance change by the Womb normalization. And also we can use the multi-dimensional scaling plot to plot the samples. Because we have 6 samples, so let's make the plot first. And we can zoom in. You can see all my 3 0 time point samples are clustered in this area, and all my 24 hours culture samples are clustered in this area. So they express similar genes between the 0 hours samples and similar genes between the 24 hours samples. So after the sample clustering, we can perform linear model filtering and differential expression analysis. So this is done by the HR package. So first we can run the linear model filtering. Then we compare the 24 hours cultured cells sequencing data with the 0 time point sequencing dataset. So now we can access the differential expression using E-based moderated t-statistic analysis. Let's run. Then we run the decide test, and now we can make a summary to see the downregulated gene numbers and the upregulated gene numbers. You can see we have 1,940 genes are downregulated in the 24 hours cultured samples. Then 3,292 genes are upregulated in the 24 hours cultured samples. With all the differentially expressed genes are saved in the fit contract data frame, so we can have a look at the top 10 differentially expressed genes in this dataset. Let's run. So you can see we have the gene ID in the first column, the length, then log fold changes. Then average expression, we have the p-value and the adjusted p-value for the differentially expressed gene analysis. Okay, so I'm going to finish this demonstration. This video tutorial takes a long time to run, but I will cut off the running time for the mapping process. So if you have sequencing data and you want to use Rsubread to do the analysis, I will post my code in the comments under the video. Then you can use the code and just change the sequencing dataset name to your dataset. Then you can run the analysis. So I hope this video can help your data analysis. Please subscribe my channel if you haven't to do so. And see you next time in my video tutorial.